this blade like this. So they increase the C very largely, 50% more, 100% more, something like this. Because like this, in fact, when you have a problem starting from there, you see that you have a much longer distance to contaminate the whole blade. Before that you are entering into a surge situation, you need to have a much larger contamination or boundary layer separation if you have a much longer C, like here. And this is also a way to solve, or let's say reduce this risk of surge. It's not reducing the risk, because the risk of having a leading edge separation or a large trailing edge separation is always existing, but it's reducing the risk without solving the risk. And these are the blades that are called wide chord blades, very often used in the fans, that you can also use, let's say, further down in the compressor. We will see that wide chord blades can be also very useful in a problem that I will discuss later on today, which is the problem of distortion that I have already discussed in the past. Okay? So you see there are solutions, let's say solutions to retard the problem, to try to solve the problem, but this problem can still take place, especially with degradation of the blades and of the gaps, the clearances that you have at the tip of the blade. But by using variable inlet guide vanes, by using variable stator vanes, by using a bleed strap, by using wide chord blades, you can reduce this risk. Of course, something that I have not mentioned yet, a problem that you have also with variable inlet guide vanes. Variable inlet guide vanes, I remind you that they do not exist normally. So this is increasing the weight for sure. But a problem that you will add also by putting variable inlet guide vanes, this is noise. You will introduce a lot of noise because you have the intake is here, very short, and the noise will go directly outside because you are creating a lot of noise at the interaction between a non-rotating blade and the rotating blade that is here. So noise related to variable inlet guide vanes, this is a big problem. And so in civil transport aircraft, normally no variable inlet guide vanes. You know, in civil transport aircraft, they have only one stage in the fan, so one stage in the fan. So they will have the fan. Later on, there will be a stator, and maybe you will have inlet guide vanes in the booster, or maybe in the high-pressure compressor, but not in the fan, to be absolutely avoided. In military engines, this is different. They will sometimes have, still today, variable inlet guide vanes because the intake is much further down compared to the inlet guide vanes, and so the sound must propagate over a much longer distance. So the situation is, let's say, different. And so as the civil cannot take variable inlet guide vanes in the fan, they need to go for wide chord fan blades. Wide chord fan blades will be the only solution they have. And so they will take almost always blades that are very long in the fan, as they cannot take variable inlet guide vanes in these applications. And there is still something that we need to discuss. Now that we have discussed about, let's say, surge, rotating stall, solutions, problems of multi-stage compressors, we need to come back to our question of the surge margin. So what will influence the surge margin? So I have solved all the problems. I have white coat fan blades, I have variable stator vanes, I have solved everything. How can I still have problems? Because if I've solved everything, why do I still need to introduce a search margin? I have solved all the problems. So the search margin could be 1%, not 20%. Why do I still need to take a large search margin, whereas I have apparently solved all the problems? I will discuss that after a break.